Hi, so this short video is going to address a problem from, this is a problem from chapter 11 test that somebody asked me via the Ask My Instructor feature of Pearson. And so a couple of things. One, I'm glad people are doing the chapter test. Remember that we're having an exam coming up. And then the chapter tests are, as soon as we complete a chapter, they'll show up. And these are not due until the end of the quarter, but it's a good I would imagine that it's a great resource for you guys to do as a review before the exam on Wednesday. So in any case, this is a problem. Let me look it up. It's problem about if I see it correctly, it's a relationship between the volume of a tuber and the amount of time it has been growing. And it's something, I think it's problem, I don't know which problem is it, 11.8 section about rate of growth and applications. So I'm going to just do the part where it asks for the derivative. It's part D of the problem. So in any case, what surprised me is that the book, when it does this, and probably does this to have all the examples straightforward and have students think of it only one way, but it's not the standard procedure to solve a derivative of this function of this sort using the quotient rule. And that's what the book does. And when you click on, and I want to see an example, they solve the derivative doing the quotient rule, which is not common. So let me see what I mean by that. So this function has something of the sort, the quotient rule says that if you have a function, let me erase this, if you have a function of the sort u over v, then the derivative of that function, you have to find the derivative of the top, minus the, sorry, let me erase this, the derivative of the top times the bottom minus the derivative of the bottom times the top. We write like this, all that divided by the denominator square. And that's the quotient rule, and it's great, we need to be able to use it. But in this case, if you think about it, in this case, what's going on? Well, the top is not a function really, the top is really just a constant. So it's a little bit too much that we ask us to do this. This top here is not a function, it's a constant. So for example, think that's a 5. Then in this part here, you're taking the derivative of 5. So there is no need to take that derivative. So just right here, that would be a 5. This part here becomes a 0. The derivative of any constant is a 0. So you can erase that, right? And we don't need that part. All this is a 0. So all you need is this part, right? It's a constant times u prime over v squared. So, and what happened here is that we don't need to do it this way, because if you just look at, oh, all I have is something divided, or I keep with red, sorry, by a function. And I want to take the derivative of that. The best way, or the most common way to think about these, is to see this as a power. This is the derivative of something to the minus 1. And then all you have to do is do the kind of like a chain rule with a power. The derivative of that would be this would be the negative 1 comes down, it's the power, and I have the function is now to the power of negative 2, and then times the derivative of v. This is the chain rule. Okay, so if you rewrite this, this becomes negative v prime over v squared. This is what happened. And as I hope you see what I said, I just use a power rule. The derivative of something to the power of n is n times that function to n minus 1. In this case, n was negative 1, so it becomes negative 2 after you subtract 1. That how this negative shows up, and then the denominator is squared. In fact, this is a way to prove the quotient rule using this rule and the product rule. So in any case, there's no reason to use the quotient rule when the numerator is just a constant, because all you're doing is taking the derivative of the function on the top, and you have a constant on the top. So there you go. So if I want to do the example, if I want to do that derivative, let me erase this and do it. You don't have to memorize this like a formula. You just do it on the fly. I'm going to write I'm going to change color, sorry. Let me go back up. Sorry if you understand what's happening. It's a little bit annoying to use my software here. Let me go back to, I don't know, blue. So I'm going to find the derivative of this guy. All I need to think about is I'm doing, the 1400 is a constant now. And all I'm doing is that I have the function, or the composition, sorry, 1 plus 1059 e to the negative 0.0245 t to the power of negative 4 to get rid of that function. Okay, so due to that function, I can forget about the 1400 if you want, because it's just a constant that will stay outside. So just get rid of this part and then multiply with the constant. Okay, so what's the derivative of that? Well, it's pretty easy. It's going to become 1400 times the negative 4 comes down, that's the power, times this thing to the power of n minus 1, which is going to become 0.245t to the power of negative 5 now, correct? And now times the derivative of the inside, which I still need to do this part, right? The derivative of that becomes another 1059, so it's a constant times the function e to the part something, and then times e to the something, derivative is e to the something times derivative of that something, so I'm going to write it down right here. It's a negative 0.0245, and I'm not going to have enough space. Oops. I need to write still the e to the negative 0.0245. Something to be careful here with the signs. There's a lot of things going on, but it's not. This is a little bit easier than doing the. There's a little bit less writing than doing the quotient rule. It's still the big chain rule, but it's a little bit less work. So let me go over this again. If you this will help. So what happened? I'm doing this power here. If I can zoom in, this power here dropped down here and became now to negative 5. Okay, so this function to negative 5. Now I need to find the derivative of the inside, which is the 1059 times e to the negative 245 times the derivative of this part, right? And the derivative of that part is still, since it has a t, it's just the constant in front of it. That's what this is. If you see what happened, I'm going to do these red parts. Now, if you follow the example from the book and if you know what's going on, then they ask you to cancel something to the 5 because they have an extra part there and something's going on. So, in any case, this is just a real more straightforward approach to get this. Okay, so let me simplify this a little bit. And there's not much more to do. I'll just leave the math for you guys. But I want to point out that since there's two negative numbers right here, once you multiply them, you're not going to see negative as your answer, right? It's going to be a positive, right? So you're going to have a positive number in the top, you're going to have a power of this to the 5 in the bottom, and this would be in the top, okay? So this may be a little bit more shorter way to do it than doing the quotient rule.